Alright, it is Sunday, day 5 on our series, or day 4, one of those. Anyway, I want to finish talking about the torque curves and we could finally go in the game. The points which we chose to get our numbers were the initial torque right here, then we got our maximum foot-pounds of torque that our engine makes in blue here, and maximum horsepower and the RPM that we got right here. Now let me talk about the difference between brake torque readings and maximum horsepower. Basically, from the previous video we got indicated mean effective pressures and brake mean effective pressures. Let me rephrase it pretty quickly. The indicated pressure is measured in PSI, and that is the pressure that happens inside the cylinder at the moment of explosion. Then we'll lose some of that PSI due to friction and pumping air and fuel in and out of the cylinder. Not everything basically reaches the crankshaft in terms of usable energy, which I'm gonna get here in orange, and that's our plus. This is our brake mean effective pressure, the useful work that our engine is doing versus indicated IMEP. That guy is what we're producing initially. If we had no friction, then the two would be the same. Now in torque right here we are measuring maximum brake torque. The way they measure it is they apply a brake to the flywheel, kind of like a brake pad on our disc rotors. Right here, let's say they're trying to slow down the engine and they're applying the force. They're applying, let's say, 200 pounds, and the engine can overcome that easily and keep spinning, you know. They're applying 400 pounds of torque and the engine still is able to overcome it, you know, and spin about, as we could see right here, about 1500 RPM. But now when we apply 604 foot-pounds of torque, our engine cannot accelerate, cannot produce any more. Then as the RPM progresses, the piston has to travel faster, there's less time to fill the cylinders, so we start losing torque. The torque starts falling off of with the RPM. But basically the optimum brake horsepower and the optimal brake torque that we're going to develop is going to be produced at this range right here, 3800 RPM. And right here, as you can see, we have a measurement down of 440 horsepower. That's brake horsepower, BHP right here. That's how much we got to do the actual work, the pushing and accelerating of the vehicle. Now indicated horsepower right here is measured by a device called indicator, which measures the pressure inside the cylinder right here. It doesn't use the brake to stop the brake horsepower that's reaching the crankshaft. It just measures how much PSI we got here, and then it applies this to the formula times RPM divided by blah 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 blah. The whole math starts running right there, and it tells you that at this RPM 6500 we get in this much pressure, which could be translated to 638 indicated horsepower. Basically what it is a lie. The engine is capable of producing this much, but only so much is going to reach the crankshaft. That is what they're not telling you. Basically this number right here would mean a perfect horsepower with no friction and no pumping losses. It's measured inside the cylinder before any pumping and before any friction takes effect to make it into brake horsepower and reach the crankshaft. Basically this number right here is measured at the top of the engine. This number right here is measured over here at the top of the engine, and this number right here is measured at the crankshaft at the bottom of the engine. And this is the theory between indicated and brake mean effective pressures. Now let me make the main point. Torque number 1 right here, we're not going to be talking about this one for now. The main two values that I want to talk about is this guy and this guy. Following our calculations and our theory, this guy will end up being a brake mean effective pressure, BMEP, while this 79 guy ends up being calculated from the indicated horsepower and ends up being the IMEP. And this is the next step, the next problem that we face is that we need to adjust these to be equal. We're either gonna run the brake mean effective pressure values all over the place, or we're gonna run the indicated mean effective pressures all over the place. I'm gonna start with brake values right here. Boom, 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 and switch to indicated values here. Basically, these are going to be your IMEPs, and these are going to be your BMEPs. Let's just keep the 45 out of sight for now. We're not talking about torque 1, and I'll show you more about that one. We're just assuming that it's taken from this point right here. Anyway, if we are using brake mean effective pressures, boom, we're making our profile in BMEPs, then we need to retain this number to 115, but this guy has to be less, because brake mean effective pressure is always less than indicated. Now I hope you could see how from 79 we're gonna start decreasing this number, kinda assuming how much friction we get, and in order to adjust this we're gonna decrease torque 3 and make it less. That is if you're running brake mean effective pressures. For indicated mean effective pressures, right, follow me here carefully, we're gonna keep the 79 because it's already an indicated mean effective pressure, and this guy has to be increased, right, because BMEP is always less than IMEP. So if we got 115 BMEP, let's assume that we lost about 15%. I'll show you how I came up with this number. Let's say we gained about 15% and about 132. So this number has to be more. Basically we have two strategies that we're gonna be running. Strategy number 1 is running BMEPs. Strategy number 2 running IMEPs. And this is how we're gonna adjust our numbers. For the BMEP we're gonna decrease torque 3 because it's in IMEP, and if we want to run the blue IMEP we're gonna increase torque 2. I hope you caught me right there, but this is what our numbers are going to be. Basically, how would I draw this out? I'd say vice versa. We're gonna adjust them back and forth between the two and see what kind of results we're gonna have. With torque 1 we'll talk more about that one, but for now it's these two guys that are more important. And on this note, I hope you could do your own little research and find out more differences between brake horsepower and indicated horsepower. Always Google, always research yourself, just to kind of get everything here clear in mind. But this is our original profile which we calculated in the first video. Oh, come on. There you go, right here, 45, 115, 79. And this is the two profile versions that we're gonna have, the BMEP version and the IMEP version, these two guys. And basically we are going in game next video on Monday, and we're gonna run numbers and we're gonna make our adjustments, and I'll show you how these torque curves change when you mess around with torque 1 or torque 3 or torque 2. They're all dependent on one another and they all shape the curve. Like you could adjust torque 1 and it'll affect how much horsepower and how much RPM you're going to develop on torque 3. So they're all dependent between one another. Anyway, I will kill the video right here. Happy Sunday anybody. It was a cool race on Texas. See you later tomorrow.